Okay, so most of you are very quiet during that. So I got one question from Brian, which is a very good question. The question was, how close has a predictive modeling matched trials paired with BMMs? I'm assuming you're talking about the stochastic model. Very well. So, I'll qualify that first. So it depends on how good your database is, or how many measurements you have already existing, because the more blasts you've measured, the bigger your database, the more accurate you're going to get a statistical distribution fitted to that database. But having said that, so the example that I showed in Ghana, that was based off 16 blasts of all the same rock type and the same type of blast. And that fit very well to the actual measurements. So yeah, so I hope that answered your question. A question from Jimmy: how can we know how many BMMs should be placed in each blast? That's a great question. It depends on the type of blast and how well your QAQC is. If you've got good QAQC and you're getting the loaded explosive per hole as per design, if you've got constant free face conditions, if you've got one type of tie-in, so you're firing to an echelon or you're firing to a free face, depends on the consistency of the ore body as well. If you've got a nice big homogeneous ore body, then you won't need many. On the converse of that, if you've got a narrow vein gold deposit with not the best QAQC practices, well then I'd definitely recommend more measurement systems, whether it's BMMs or if it's stakes or whatever you're using. Edward asked, can the SMU dimensions produce ore loss and dilution? Should we select the optimal SMU to reduce or eliminate the ore loss? Yeah, look, absolutely. So, for instance, if you have a very narrow vein ore body, which is quite common in gold, if you're digging with a shovel size that's just simply too big, or a bucket size that's simply too big, then that in itself is going to cause ore loss and dilution, irregardless of whether or not you measure it with BMMs. So definitely you need to get your SMU size appropriate for the type of ore body that you're excavating. John, so after blasting using stochastic modeling, you simply use use GPS markout. So the stochastic model, as I showed, currently it's in Excel, which is good in a way because you can then export the post-blast boundaries in CSV format or in text format, which in most mine planning softwares will be able to handle very easily. So you can just bring them in and then give to survey to mark out. Okay, Andrew asks, the stochastic model produces two possible boundaries. How do you use those two boundaries in practice? Yeah, look, so the two boundaries, that is based on the confidence interval. So if you have a confidence interval of 50%, you'll get the same boundary. If you want a confidence interval that's higher, say 80, 90, 100%, then that boundary, or the distance between those two boundaries will increase based on your database. So the example I showed, the distance between the two boundaries is like less than 3 meters, which, going back to the SMU size, is probably about your SMU size that of your shovel that you're using to excavate. So general practice is you'll just use the midway region of the boundaries, but it does depend on the site. So if you're more concerned about reducing ore loss, you'll use a different boundary as to what you use if your big concern is reducing dilution. Patrick asked a question: what percentage of mining operations do you believe are applying best drill and blast practice in the context of your talk? Well, that's a loaded question. I can't comment for every mine site. Obviously, I haven't visited every mine site, but the mine sites that I have visited are generally those that want help with reducing ore loss and dilution. So they've already taken the first step in trying to reduce it. The bigger problem is it's the mine sites that don't know they have a problem, and they just continue on with situation as normal, and worst case scenario, don't measure blast movement at all. Mario asked, what is the input information required for the calculation of stochastic model? So the inputs there is a database of existing blast movements. So the bare essentials are the type of blasts, the design inputs, so the burden, spacing, powder factor, the rock type, and then the existing movement, the direction and displacement that you have for those blasts. If you have a good database of that, then you can fit a distribution to it and use that to predict future movements. David's asked a question, how do you take 3D movement into account? That is where ore from the bottom flitch swells up into the top flitch. Great question, David. So most sites will just measure movement on the mid-bench elevation, and you can get away with that for certain situations. If you do have a highly variable ore deposit, or if you're mining on flitches, for instance, then it is recommended to measure movement in flitches. So you split the bench up into a bottom and top flitch, and you can measure the movement. Based on that, with BMMs, you can put in as many BMMs as you want into the blast to measure multiple flitches. Again, then once you have that database of the movements by flitch, then you can simply apply the stochastic model in the same way that you'd apply just using the mid-bench elevation. Mary asked a question, does the stochastic model take into account problems with the blast, i.e. misfires, overloading, stemming issues? No, it doesn't. I wish it could. So the stochastic model simply predicts the movement based on what it's done in the past, so the measurements that you've taken in the past. Now, before you can apply a stochastic model or even a template model for that instance, you need to have consistent movement. And to get consistent blast movement, that means you need to take account or get those problems under control. So if you're constantly overloading a blast or having misfires or stemming, that's your number one issue to deal with. So you need to have good QAQC to get good consistent blast movement before you can look at applying a model such as a template or a stochastic model to predict the movement. I had a question, can you present exactly the same topic underground? I can. I haven't got anything prepared, but yeah, definitely I can do that if there's enough people interested. Yeah, good question, Brian. So how does the stochastic model treat movement close to the center line of a V initiation? So the stochastic model, so generally movement will move perpendicular to the atomic contour. So your question there is what happens at the center line of the V, and what it does in that case, and I'm pretty sure what it, similar to what most models do, is it just moves parallel to the V initiation. It moves straight along that same line, which is essentially what happens. So if you have blast moving inwards towards the center line, it's going to hit that center line and move forward. So John's asking, small mines have less capacity to adopt more sophisticated modeling, but the most to gain from minimizing oil loss and dilution. Have you any recommendation like survey movements to help predict? Yeah, so smaller mines or quarries, even in that instance, if implementing BMMs is a step too far, simply using surface stakes or polypipe or chalk or paint is better than nothing. Look, it's not going to be perfect, and it's not going to tell you exactly what's going on under the surface, but it is quick, it's very cheap, and it's better than doing nothing, definitely. Okay, so Brian's clarified his question. So he means on either side of the send line. So on either side of the send line, so one of the inputs into the stochastic model is the direction, the primary angles of the direction of the blast. So if you take into account, say, blast movement is generally perpendicular to the timing contour, one of the inputs is what those timing contours are and the primary direction, and then on that it adds the variability measured from the previous database to then estimate what's going to happen. So it won't move exactly perpendicular to timing contour, but it will have some variability. Okay, I hope I got all the questions. If I skipped over any, please just throw it in again, or otherwise I think I addressed all of them. So again, thank you everyone for attending the webinar. It was good attendance, and very happy to share what I can with you. And if you have any follow-up questions after this, please feel free to email me. I will send out the presentation. I have everyone's contact emails and details, so I will send out the presentation. And yeah, if any questions come after presentation, feel free to contact me, and we can take it up further. But yeah, thank you, and keep well, keep safe, and thank you again.